Good afternoon, everyone, and thanks for coming to the breakout session today on Hedvig and our description of a universal data plane. Hedvig's a software-defined storage company based in Santa Clara, California, and I'll take you through a few thoughts we have, our vision for where storage is going, a little bit of how Hedvig can help you and others get there. So first off, just a thought. Gartner, in a recent survey in the last few months, surveyed CEOs, and they said, what's at the top of your business agenda? And it's not software-defined storage. Maybe that'll be next year. But any thoughts on what that might be? Cloud was suggested. Yeah, cloud maybe. So the broader topic was digital transformation. So digital transformation is top in their agenda, right? And I love this first one where half of them say that they expect their business to be unrecognizably transformed, right, by digital advances. And you can read through some of the others. 3/4 think they're expecting higher profits, and almost half the customer perceived value will be digital. I'm sure you've had those experiences too. There's some companies out there, and again, over half say there's a critical initiative to implement a digital transformation. There's some companies, we were talking about one just before we started, that have grown up in the digital age, and then there's some others that are entering the digital age. So just a couple examples from this side. Nike has wearables, and they're able to, and they have been for a while, been able to look at your running patterns, that sort of thing. Well, now actually they're able to market to local businesses. Here are the numbers and the times when people run by your store. If you're a coffee shop, maybe there needs to be a 7 a.m. let's stand out front and hit the runners at the end of their run kind of thing. And then Oral-B. So for those that don't know Oral-B, it's a toothbrush company. So how do you get digital with the toothbrush? Well, what if you had a toothbrush that could connect via Bluetooth to your phone and then beam back statistics and information on your brushing habits? Now, as far as I know, they're not going to call your mom with that. But it's an interesting thought to think then that they can enhance your brushing experience. And by the way, they're charging, as I understand it, a premium. That's an almost $100 toothbrush, right? But those are just a couple examples we don't think about digital transformation. So you need to have the right kind of infrastructure then to be able to implement that sort of digitization, right? So you may need some orchestration and modern workload tools. And we've talked about some at the keynote this morning here at Delta, where we heard some thoughts on containers and Docker, but that's just one approach, right? So there are a lot of different ways that people want to go about managing this environment. And also, of course, there's the public cloud, and that's of interest too. So back to the thought that perhaps the cloud is the place for the future. The fact is that companies are often looking at how do I get to the cloud, and for that matter, then how do I operate in a hybrid cloud world where I have some data on-prem, some in the cloud, some both places. What do you do with your data infrastructure? Can your data infrastructure support that? So what we're going to talk about today is our vision for the universal data plane. And the concept and the thought was coined by our founder, Avinash Lakshman. He developed the Dynamo technology that's behind the Amazon shopping cart, and then went to Facebook. And going from a team developing Dynamo, he was the developer for Cassandra, which has now been turned over to the Apache project, but is certainly a very scalable data management platform as well, now bringing it to the general purpose software-defined storage. So what we think of when we think of a universal data plane is you need to be able to manage any kind of workload, whether, again, it's virtualized, it's containerized, it's on bare metal, across any tier. So whether you have requirements that might include high resiliency and replication for DR or higher or lower performance. And then across any cloud, right? Whether it's a private cloud that your company has implemented, or again, public clouds, or some kind of hybrid of the two. We need it to be able to be programmable. So in a DevOps context, can you manage that environment, and can you get the most out of it and quickly make changes or enhancements to get additional value from your platform? So again, spanning all the workloads, clouds, and tiers, enabling data portability. So what does that mean? That has a couple connotations as well. In a more traditional sense, it might mean, can I have copies in different sites where one or more of those sites might be a cloud? But if you think about the cloud world today, there's a notion that as you put things into the cloud, you can access it. If you were to decide later, hey, I'd like to use a different cloud provider, one of the more challenging aspects of a cloud implementation is there's a significant cost for data egress in the cloud, so that you're having to pay to get your data back out of the cloud to perhaps put it somewhere else. And again, we have a solution that addresses that, and I'll talk to it in a minute. And at the same time, being very aware of the locality of the data, where is this data stored, where is it used, and be able to, in effect, assure that there isn't a single point of failure that's gonna impact the availability of that data. So that to us is what the universal data plane is all about. In today's world, you might have multiple data layers, right? Different protocols, the more tried and true SAN and NAS, something newer in the object space. Do you have other data platforms that you use for backup? Do you have others when you need to replicate for enhanced disaster recovery, right? And in the same way, what's the high availability strategy? At the application layer, again, as we talked about a minute ago, what does that look like? Is it virtualized? Are you now beginning to start to work with containers? And do you have a cloud in your equation today, or is it coming soon? Right? Those are all different application layers that can come into play. And then, as we talked about as well, orchestration. Kubernetes, Mesos, were some on the previous slide. Those have been out there a little while. Those were talked about in today's talk, as was Swarm. So another technology from Docker that plays at the orchestration layer. And then, of course, the virtualization, the hypervisors are a type of virtualization, and many people would argue that, a type of orchestration. And many people would argue that OpenStack really came out of an effort to simplify orchestration, perhaps away from the hypervisors. But these could all be different layers, and it gets to be a pretty, big Tetris puzzle and a pretty big piece. So if we're able to provide a data plane that works across those various levels, then that greatly simplifies your solution, and simple should translate to better performance. It should translate to better availability, and we're all in this for business. It should translate to a better total cost of ownership. We can see as well that we'd want to be able to spin up different workloads based on business policy. We should, by the way, be able to apply that business policy to the individual volumes or applications, and be able to protect them globally, and also at some level at a customized way, right? So again, certain applications may have different demands than others, and you should be able to be flexible with that. And again, trying to avoid that cloud lock-in, those egress charges that I talked about. That's another key part of what we're doing. So again, Hedvig is out there. It's software-defined storage that really we have 5 capabilities that we think are critical to this. Being able to scale out. So again, from just a few storage nodes to hundreds or thousands even, built with the notion of replication native to the product. So it prevents no single point of failure, and it also gives you control over where your data locality, how you implement data locality. It's built for automation and for orchestration. So in particular, you'll see that Hedvig has a REST-based API, a CLI, and a web GUI, and those are all available to you to again implement, to enhance, to modify as you need. The application awareness should be there, and it is. So you can custom tune by application, and it's built for operational simplicity. In fact, you can use it on an iPhone. We're not going to do that today because I don't know about you, but I've made a typo or two on my iPhone. But I tell people over the years I've been asked, can I run something on my smartphone? And can I run my storage on my smartphone? And I've always said, no, would you? And they seem to say yes. So here's a product that you can run on your iPhone or your Android device, as long as it doesn't smoke, right? But your iPhone or your Android, and I'm not yet aware of a customer that's doing that. So we'd love to have you be that first one. So here's a list of features, and let's talk about it. We will operate with any x86 platform. We also have designed the product to work with ARM. We still believe ARM is coming. We haven't seen the uptake yet, but we run and are implemented in a way that keeps us independent of the underlying hardware platform. As we've mentioned already, we're aware of different sites. They can be multiple data centers, they can be clouds, and we can replicate between all those. We have both a hyperscale and a hyperconverged deployment, and I'll get into that in the next slide. We'll run with any client because at the end of the day, and that can be, by the way, a bare metal, a hypervisor, any kind of OS, a container. But at the end of the day, we're providing block file and object. We're providing specifically iSCSI, NFS, and S3 or Swift or Swift in the object space. So any compute platform that can access storage using one of those protocols is a candidate for Hedvig. This second to last bullet is really key, and I'll show it a little in our demo. But these features are granularly available per virtual disk, per logical volume. So we can have a virtual disk that's NFS, that's replicated across multiple sites, and then we might make a copy of it and have that only available locally or agnostically. We don't care, right? We might do the same thing then in terms of dedupe, compression, right? We may turn that on or off per virtual disk, per volume, where it makes sense. If an application is not conducive to dedupe and compression, why do that? And so today we don't. And in the same way, we have the ability to move data, to make hot data more readily available. We can cache. for increased performance, and then handle snapshots and clones. And again, I alluded to it earlier, but our clones actually allow us to change these characteristics, so we're able to do that as well. So let's look at one slide on how we work today. Here's a Hedvig cluster. We have, in this case, 9 commodity servers running Hedvig software, and we've told each of those, we've told the cluster that 3 of them are in data center 1, 3 are in data center 2, and 3 are in a third site that happens to be in the public cloud. So we have these instantiations of our server nodes, our services. Up here, we have different client environments. Again, we've talked about this a couple times. There's a hypervisor, there's maybe a Docker engine, and some bare metal servers as well. Well, what we can do next then is we can tell the cluster that we want to present virtual disks that have the following policies. And in this particular example, we've suggested, and maybe this is for all 3, and maybe it's for one of them, it's going to be a block virtual disk with deduplication enabled. It's going to have 3 replicas, so we're going to replicate it across all 3 of those sites. And the fact that it's DC aware tells us it's going to replicate across all 3 of those sites. And we have caching turned on. And then we have a second tier to our architecture. So in addition to this tier down here for the storage nodes, we also have a proxy service, and it's indicated by the green up at the client level. And it's going to provide some level of caching. It's also doing the translation. So that's what speaks block, file, or object to the clients. And then it speaks RPC calls down into our cluster to take the necessary operations to implement the virtual disk policies, store the data, that sort of thing, right? And then when a write occurs, in this example with the replication factor of 3, we're going to make a write to one node. It's going to know about the policies and say we need to make 2 more writes. Because we're a distributed system and we follow distributed system principles, we're now going to take a quorum. We're going to ensure there's a quorum written. So in this case, 2 out of 3 writes, we're going to get acknowledgments back that they've been successful, and that's when we'll acknowledge it up to the host. The third write will also happen eventually or asynchronously from the other writes. The fact that we do a quorum write, and then by the way, when we're reading data, we do a quorum read, ensures data consistency. But we're able to use this semi-synchronous replication policy of synchronous to a quorum, asynchronous to the rest to increase performance. Finally, we can implement these servers as virtual machines. The proxies can be virtual machines. And so we could run this all in a hypervisor for a hyper-converged solution. You know, I encourage you to stop by the Hedvig booth. We have a hyperscale for dummies book, not because any of you are, but for your friends who are, to be able to see, you know, our take on when hyperscale makes sense, which is more this approach, right, in different places where we have the data storage independent of the proxy or the compute layer, the client layer, and when it makes sense perhaps to bring them together. So before, I'm going to go into 1 or 2 particular examples, but any general questions on how we work before I do that? Okay, so thanks. So and I'm going to repeat the question for the folks out on the stream or in the recording. So are we an OS or an application running on a system? So Hedvig itself is software that runs on top of Linux. In fact, we implement a version of CentOS minimal on the storage nodes, and then we run on top, and that's how we work on the storage nodes. Oops, I'm sorry. And then in the same way, the proxy, whether it's a VM or a container or bare metal, is something. It's a VM, a container, a process, again, running in a CentOS or on top of a CentOS environment. And that's what gives us, in part, the portability, is because that CentOS can be run on top of any platform, and we run on top of that.
How do you do the hyper-converged part of that?
So in the hyper-converged world, at that point, these are VMs running in the hypervisor. Yeah. But if, for instance, if you were to look at a proxy VM, it would look and feel like a Linux system. You can SSH in and do that kind of thing to it. All right. So one example is, and we're hardware agnostic. We do work with different server providers to provide reference architectures to do different levels of qualification. And we did one with Quanta for DockerCon that I'm highlighting here. So this was a reference architecture where we were able to use some servers from Quanta, and we'll show them on the next page, but they're very interesting in the amount of storage they can get in one use. So for a storage company like us, that's a very interesting capability. But basically, we were able to run our software and implement on top of Docker, with up here having a Docker engine, and we use different applications to test it through, again, including Docker Swarm, and very simple implementation at the end of the day. And we have some video of that we can share with you, or we could do a demo for you, the video at the booth. But here's that server, and again, just to point out, they're able in a 1U chassis to put 12 3.5-inch drives, so maximizing density. And again, we have customers with any number of different server vendors, but that was one that was appealing to us. And it also has some flash as well. So these particular were configured in this way. And I just point out something I haven't talked to specifically. We use the SSD then for caching and for write acceleration. So we do journaled writes. We have journals out on the SSDs, and we're able to write to those and through them into memory, but that allows us to provide persistence for those writes in case there was a problem with the server. So when it comes back up, we'd be able to play forward and get that right. And in this particular case, this was 12 by 6 terabyte drives, which seemed pretty large a few months ago. Of course, the sizes continue to go up. But getting you effectively 72 terabytes of storage before dedupe or compression, and I don't know that I mentioned it, but our system globally thin provisions as well. And we did need 10 gigabit Ethernet. That's how we run in our back end and between the nodes, as well as serving the data out. So that's what a server might look like. Again, it might look very different. We can be very flexible and customize that with you. Here's another example of virtualization, and also perhaps being in two clouds. And there's a couple things interesting in this. So here are some hypervisors with proxy services and VMs, and then storage nodes down below. And we have those in 2 data centers. And then we also have a cloud with similar kind of approach. This is meant to show cloud, bare metal clients perhaps, or the equivalent. And look in cloud too, there's no storage nodes, but that's not to stop us from, through the proxies, accessing storage in other sites. One thing that I think sometimes is harder for customers to understand is that all 12 of these storage nodes form one cluster. This is not 3 clusters of storage node. It's one 12-node cluster. And that data is available where needed throughout. And so again, this example does help show that. So there's zero data here, but I could access everything that was provisioned to these proxies. I could do that through this cloud. So again, there is a notion of locality, and we can be aware of it. Obviously, there's not too much locality here, but there's the functionality to make it available. So very flexible. That's what I hope you take away from this. Another point too is, suppose in these data centers, suppose I started with 2 hypervisors. As I grow to a third, I just add a proxy there, and now I've increased my host I/O, my host-facing I/O capability as I grow my host. So again, in a hyperscale mode, I'm growing my resources where they're needed. Sometimes in hyperconverged, we can run out of processor before storage or storage before processor. An advantage to hyperscale is we're able to grow where and when we need. Here's another common use case for us, which is backup to disk, right? And with some level of replication. So we're able to do this again. And in backup to disk for us, we do tend to use physical proxy servers for the higher ingest rates. As noted here as well, the proxies can be configured active-passive, so in an HA pair, so if one goes down. That also works in the VM space as well, and they're most commonly done as an active-passive pair for additional availability. So again, the backups are done, and as noted here, that data may be done in one data center, but it's available everywhere. So we really are active across the whole cluster in that context, regardless of the number of sites. So I'm about to show a little in a demo. Any questions before I go there on the slides? Okay, so let's do that for a moment. So here I have a 6-node cluster. As you can see, we've defined 3 data centers in Santa Clara 1, 2, and 3, each with 2 nodes in it. We're able to tell, by the way, the cluster size, how much space is used today. We have a concept of individual pools of storage. I could click in right now. There's no I/O going on, but I'd have some visibility there. As well as, in addition to those storage pools, we also have what we call our pages process, which is metadata. And that's where we're keeping information about what are the locations of the various nodes, what are the policies of the various virtual disks. One thing we track at a cluster level is what are the relative latencies between the nodes, so that we can make efficient choices when we're going to do a quorum read. Where are we likely to get the fastest results? So we're aware of all those things within the cluster, and it's managed that way. And again, by the way, this would look the same in a hyperconverged setup, right? The components, the tiers are still the same with these nodes. And then I also have 2 controller virtual machines, another name for proxies. So I have 2 set up. I happen to know, and we can see it a little in this diagram, that this is in fact an HA pair. This is a VIP for those 2 HAs, a virtual IP. And I've configured these to do both file, so that one, and block. So I won't be doing object here, but that's reflected in the GUI as well. So one other thing I think we've talked a little about, the GUI itself, and it is skinnable, right? So we can have different themes. Here's a little retro look for those of us that haven't seen that in a while. So next we'll be putting Pong in here maybe. But I'm going to go back to that one. And again, this would look the same on your smartphone or tablet as well. So here's a virtual disk management page, and now I'm going to be able to add a virtual disk. And so I'm going to start with adding a block disk. And there are a lot of options, as we talked about earlier. There are a lot of options that are available per virtual disk at that level of granularity. Everything from, do I want to make this available for raw device mapping, RDM? Am I going to present this up directly to a virtual machine? Am I going to enable deduplication? Is it going to be clustered file system, iSCSI3, compression? Client-side caching is where we can take advantage of flash in the proxies. That's going to result in better read performance. And sort of what sort of replication policy? So let's make this data center aware, and let me pick some data centers here. So I'm going to replicate this one across all 3 data centers. I'm going to leave it on a hard drive. Certainly if there were flash, we could make it resident in the flash as well. And then, we have a notion of role-based access control, so I'm going to leave it at the Hedvig tenant. And I'm going to do that. I think I did everything except hit the right, sorry, I did do that. So here's this, let me get out of that. So here we are, and now I just need to make it, because it's LUN, I need to make it available on a proxy server. So I'll just pick one. And that one was data center aware actually. Why don't I make it available everywhere and run it? And now that's available. And I could further then put in host access control. But in the interest of time, I'm now going to do something I think is pretty interesting. I'm going to snapshot it. And that's a pretty straightforward operation. And then from that snapshot, I want to clone it. And when I clone it, I get to specify some other characteristics. So maybe I don't care about this one so much, so it's agnostic. I only want one copy of it, right? And it had client-side caching? No, because maybe this is for test dev, and we have a description we can put in as well. This helps with management and recording. And so I run that, and now I have a clone, and I could similarly present that out. And in the NFS world, it would look something similar. We also have a VMware integration. In the interest of time, I'm not going to show that today, but that's another piece that you can maybe see on here. There's a Hedvig data store, and we're able to work with VMware directly through vSphere. Again, we have integrations with Docker, more to come, I'm sure. So, any last questions?
So if you do a file share, is there a size limitation?
Do we have a limitation on file share sizes? No, the thought is no, that we should be able to share a file of any size, right? So, in terms of volumes and volume sizing, those are things that are continually evolving. Let me just, because I'm getting the high sign, so let me just finish with this. So what you've hopefully seen today is a very flexible platform, and one that would enable a very flexible access to your data wherever it is, in whatever format. So again, any workload, any tier, any cloud. Thanks very much for your time.